Hi friends. In the previous video, I was already explained the basic introduction of 8251 IC, also call it as a universal synchronous, asynchronous receiver and transmitter IC, right? So in this video, let us see what is the block diagram as well as what is the pin diagram of 8251 IC detailedly. Okay, let us observe. See the diagram. See the block diagram and pin diagram of 8251. Here, see the right side part, it is a pin diagram of 8251. In that, how many pins are present total? How many pins are present? 28. See, 14 in one side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 14 in other side. Like that, total 28 pins are present. Okay, now this is the block diagram. First, let us see what are the various blocks present in the 8251. Later, we'll see details of each block. Okay, so diagram, there is a internal bus. This is internal bus line. So internal bus line is connected to all the blocks of the 8251. So then there is a data bus buffer. It is connected to internal bus in the bidirectional form. Then data bus buffer having 8 data lines, and these lines are connected to lower byte of the processor. Then read-write control logic having set of signals like a clock, ready, read bar, write bar, clock, read bar, write bar, CS bar, then C by D bar. Okay, it's a command slash data or control slash data bar. Okay, then reset signal. Then other is important one is modem control. Okay, so we know 8251 is also communicating to modem devices. For that, we are using 4 signals. One is data set ready bar, data terminal ready bar, clear to send bar, request to send bar, like that. The signals are present. Now coming to data bus transmit buffer. Okay, so it is primary to secondary. Nothing but to transmit buffer transmitting the data from the processor to external serial port device. Okay, so in order to transmit, we use TXT pin, transmit data pin, TXT. X indicates external serial port, it can transmit, that's why TXT. Okay, now this transmit buffer is controlled by transmit controller. Okay, so in that we have 3 pins, transmit ready, TXRDY, transmitter is empty, TXE, TXE bar, nothing but transmitter clock pin. Similarly, the other is a receiver buffer. Okay, receiver buffer functioning is it will take data from the external serial port and transmit it to processor. That's why secondary to primary. So receiver buffer receiving data from the external serial port. That's why RXT pin is essential. And receiver buffer is controlled by receiver control. Here also we have receiver ready, receiver clock pin bar, and similarly synchronous detector or baud rate pin. So like that they are connecting. Let us see functioning of each block here. First, data bus buffer. You know, data bus buffer is mainly used to communicate data between internal bus of 8251 and lower byte of the processor. For example, processor wants to send data to external serial port. In that case, what happens? Processor sending data to data bus buffer. The data bus buffer receiving the data with the help of data lines, and that particular data is transmitted to internal bus. Like that, the data bus buffer act like a device for transmitting data between internal bus of 8251 and processor. Okay, for that purpose, we are using data bus buffer having 8 data lines, and these 8 data lines are connected to processor data bus. Now coming to other read-write control logic. So whether the processor is reading the data from the 8251 or writing data to 8251. Okay, now like that, the read-write control logic now this particular read-write control logic is controlled by processor. Accordingly, 8251 performing a read operation or write operation as based on the command given by the CPU. Okay, and this read-write control logic controls transmitter buffer as well as a receiver buffer. Here, if you observe read-write control logic connected to internal bus, and read-write control logic also connected to transmit control as well as receiver control. So transmission operation as well as receiver section, both sections are controlled by read-write control logic, and this read-write control logic is controlled by processor. So based on the processor commands, read-write control logic controls the transmitter control operation as well as receiver control operation. Here we have set of control lines as the reset clock, C by D bar, read bar, write bar, and CS bar. So in pin diagram, we'll see each function detailedly. Then other is modem control. So modem control modem control block is mainly used to communicate data transfer or between 8251 and external modem device. So modem control block is used to communicate information or data communication between 8251 and external modem with the help of four modem control pins: DS bar, DT bar, CTS bar, RTS bar signals. We'll see functioning detailedly later in the pin diagram. Then other is transmit buffer. Transmit buffer role is actually this transmit buffer internally having two registers. One is called it as a buffer register and other is called it as output register. So the role of transmit buffer is because of those two registers. First, for example, Prasad wants to send its 8-bit parallel data to external serial port. In that case, what happens? First, Prasad sending data to 8251. So in that case, a transmit buffer register is present. It's a 8-bit buffer register. 8-bit buffer register receiving the parallel data from the CPU. Okay. Then later that particular data is transmitted to output buffer. Okay, where the output buffer will convert the 8-bit parallel data into serial data. After getting the serial data, transmit buffer transmitting that particular serial data to external serial device via TXD pin. Okay, here the rate of transmission is decided by transmit clock pin. So based on the transmit clock pin clock range, okay, now transmit buffer transmitting bits with that particular baud rate to serial port device, external serial port device. Okay, here important point is transmit buffer having two registers. One is called it as a buffer register and other is called it as output register. So what is the role of buffer register? Buffer register receiving the 8-bit parallel data from the CPU. Okay, then the data is now transmitted to output register. Then output register takes that parallel data and converting it into serial data and transmitted to external serial port device via TXD pin. Okay, then the transmission operation is controlled by transmit control. Transmit control controls the rate of transmission of data from transmit buffer to external serial port device. Okay, transmit control having transmit ready pin. Okay, with the help of this transmit ready pin, external serial port device understood that transmitter is ready to send the data. Okay, TXE is transmitter empty. So because of the signal, external peripheral or external serial port understood that the transmitter does not have any character or does not have any data to transmit. Now this is TXE, but transmitter clock pin. So now this transmitter clock pin is connected to external timer or counter pin. With that rate, transmitter transmit the data to external serial port device. Coming to receiver buffer. Receiver buffer role is receiver buffer also having two registers. One is called it as an input register and other is called it as a buffer register. So let us see what is the role of receiver buffer. So because of those two registers, it will perform the operation. So first is the input register. So the input register within the receiver buffer receiving the serial data from the external serial port device. Okay, then that particular with the help of RxD pin. So the receiver buffer having two registers. One is buffer register and input register. So first input register receiving the serial data from the external serial port device with the help of RxD pin. So after receiving the serial data, then the input register transmitting that particular serial data to buffer register, where the buffer register converts the serial data into parallel data, and then that parallel data is transmitted to CPU. Like that, receiver buffer takes the data from the serial port device and transmitting that particular data into parallel data, and finally it will transmit it to CPU. So this receiver buffer is controlled by receiver control. Receiver control also having many pins like receiver ready, receiver clock bar and synchronous baud rate pin. So receiver ready indicates that now this pin giving information to external serial port device that receiver block is ready to receive the data. Then receiver control will transmit the data to receiver buffer at that time. Now receiver clock pin bar. Now this pin is connected externally timer or counter pin with that timer range, the receiver receiving the data from the external serial port device. So synchronous detector or baud rate. So a synchronous detector means, for example, this pin is connected to common clock of TX. For example, TX C bar and RX C bar both are connected to same clock pin. Okay, then synchronous detector indicating that they are synchronizing. Transmitter rate and receiver rate both are same with same baud rate. Okay, like that we can analyze whether they are operating like a synchronous mode or asynchronous mode of operation. Okay, based on synchronous detector pin. Like that we can analyze the block diagram of 8251 easily. So coming to pin diagram, let us see what is the role of each pin present in the 8251. First coming to 8251, you know already it is having 8 data lines: D2, D3, D4, D5, D6, D7, and this side D1, D0. Totally D0 to D7. 8 data lines are present, and these data lines are connected to lower byte of the processed data bus. And with the help of these 8 data lines, Okay, so 8086 can send the data to 8251 or receiving data from the 8251 via D0 to D7 lines. Okay, for that reason only data lines are used. They are bidirectional data lines, and with the help of these data lines, the CPU can communicate it to 8251 for transmitting as well as receiving parallel data. Now let us say other is TXD for ground. Ground pin is mainly used to provide protection against the overcurrents or short circuit problems, short circuit related problems. Then RXD. What is RXD? It's a receiver pin. Receiver pin. X indicates external. Okay, now that's why it is called as a receiver data pin. RXD, receiver external data pin. Okay, RXD. What is the role of RXD? We know in receiver buffer we have checked. What is the role of RXD? RXD pin is mainly used to receive serial data from the external serial port device. Okay, then TXD. What is TXD? Transmit data pin. This pin is used to sending data, transmitting data to external serial port device. Okay, TXD pin. It is transmitting serial data to external serial port device with the baud rate specified by the TXC bar. Okay, similar RXD receiving data from the external serial port device with the baud rate specified by the RXC bar pin. Okay, then other is write bar. So what is the role of write bar signal? So whenever write bar is activating, then what happens? CPU receiving the CPU writes the data to 8251. Writes the data to 8251. Okay. CS bar. CS bar is chip selecting signal. So whenever CS bar is activating, then only 8251 is performing the serial port operation. Means it is communicated to any of the serial port device. So 8251 must be activating only by activating CS bar signal, and the CS bar is activated with the help of external address decoder. Okay, then C by D bar. C by D bar is nothing but control slash data bar. So whenever if it is 1, then the operation is control. If it is 0, then operation is data operation. Okay, now read bar. Read bar is if whenever read bar signal is activating means by giving 0. Whenever read bar is activating, then what happens? CPU reads the data from the 8251. Okay. So now there is a one table related to read bar, C by D bar, and write bar. Let us see. Based on after that table, let us see other pins. See here C by D bar, read bar, and write bar. If you observe carefully, so CPU can activate either read bar or write bar only one. Okay, based on the C by D bar, it will perform many operations. Let us see. First, now C by D bar is 0, means we are selecting data. Then read bar is also activating, write bar is inactive. In that case, which operation is CPU performing? CPU reads data from USART. Okay, now data, so because we are activating data and we are selecting read bar, then CPU reads data from USART in that case. Now 0, 1, 0 combination. So here also 0 means we are activating data. 0 means we are activating write bar. Then what happens? CPU writes data to USART. Whereas here receiving data, here sending data to USART. Now if it is 101, 101 means we are activating read bar, and 1 means we are selecting a command, okay, or control. It's like a one status. In that case, what happens? Now we are activating read bar. Then CPU reads status from USART. Status of USART is received by CPU. In that case, 101 combination, CPU reads status from USART. For example, 110 means we are activating write bar and we are activating control. In that case, what happens? CPU writes command to USART. So here in this case, CPU reads status, whereas here CPU writes command to USART. Accordingly, USART performing the required operation with the modem controllers or with the transmitter or receiver operations. If it is 1 means read bar and write bar both are inactive or cross. It is not 0, not 1. Then USART performing floating operation. Like that, USART performing various operations okay, in association with the C by D bar, read bar, and write bar pins. Okay. Now let us see other pins. Okay. Now let us see 14th pin, RX ready. RX ready is receiver ready. Okay, receiver ready pin. See here, receiver ready pin. So this pin is mainly used to give communication to external peripheral device that the receiver is ready to receive the data. Okay, receiver ready pin gives information to external peripheral in such a way that receiver buffer is ready to receive the data. Like that, it will give you communication to external peripheral device via RX ready. Then TX ready. TX ready is also, this pin is also communicated external peripheral device that transmitter is ready to transmit the data. Okay, transmitter is ready to transmit the data. Okay, that information is communicated to external serial port device via TXRD signal. Transmitter is ready to transmit the data. Okay, with the help of TXRD. Then let us say synchronous detector or baud rate. Okay. So now this pin is mainly used to check whether the operation is synchronous mode or asynchronous mode. So whenever RX C bar and TX C bar both are connected to same timer or clock, then we can say that the 8251 operating like a synchronous mode. Okay. Then in that case, baud rate is same for both the transmit operation as well as receive operation. Whenever synchronous detector is is operating under asynchronous mode, whenever in that case TX C bar and RX C bar they are connected to different timers or clocks, then the baud rate of transmission and baud rate of receiving are different. Okay, like that we can analyze a synchronous detector. Then let us see CTS bar, clear to send bar. Then request to send bar. Then data set ready bar, data terminal ready bar. See here 1, 2, 3, 4. CTS bar, DSR bar, and RTS bar and DTR bar. All are mainly used to communicate modem control device to external modem device. So in that, let us see data set ready bar. For example, data set ready bar command is as input to modem control. Now this command is input to modem control, and this command is specified by external modem devices. It is ready to performing data set operation. Okay, it is ready to performing data set operation. Like that external modem sending input to modem control device. Then if modem is ready, it will send data terminal ready pin to external modem device. Then external modem device understood that 8251 is ready to transmitting bits. Okay, data terminal ready is a output pin to modem control, whereas data set ready is input pin to modem control. These two pins specifying the status, whether the external peripheral is ready to communicating or not. Data set ready is it indicating it's ready to communicate with modem control. In that case, data terminal ready also giving the information to external modem device that modem control is ready to transmit the data. Clear to send bar. So clear to send bar means whenever the operations are completed by the modem, then clear to send bar signal is activating. Then other is request to send bar. Okay, so request to send bar signal. So before sending the data, it will send request to send bar signal to external modem device via modem control. So generally these four are essential. Two are the input signals and two are the output signals. So these four are used to communicate the mainly data transmission operation between modem control and external modem device. Okay, so just mention only which are input and which are output. Okay, like that we can write easily. At least full names are essential: data set ready bar, data terminal ready bar, and clear to send bar and request to send bar. These four are the four control signals. They are communicating between modem control and external modem device. Okay, that is enough. Then other is TXMT. TXMT is transmitter empty. Okay, transmitter empty. This one. So now this pin is connected to external serial port device in such a way that transmitter is empty. So no data, no character is available in the transmitter to transmit. Like that, transmitter empty pin is connected to external serial port device such that it is communicating to external serial port device. No character is available to transmit. Okay, in that case, transmitter empty pin is essential. Then TXT. What is TXT? Transmit external data pin. Means with the help of TXT pin only, the transmit buffer transmitting serial port data to external serial port device with the baud rate specified by the TXC bar pin. Okay, TXT pin is used to transmit serial data to external serial port device. Then clock. So generally clock is the input pin, and with the help of clock pin what happens, 8251 receiving the clock signal from the external clock generator. Generally the clock frequency is at least 30 times more than the clock frequency range of TXC bar and RXC bar. So the TXC bar and RXC bar clock range if you consider, so this clock must be at least 30 times more than the clock frequency of TXC bar and RXC bar. Okay. Then reset. Whenever reset is occurred, what happens? So the status as well as control registers, buffer registers, input registers, output registers of transmit buffer, similarly receiver buffer. So transmit buffer having two registers, receiver buffer also having two registers. Similarly, based on C by D bar, it is having status and command, right? Control command. So all are cleared whenever reset is occurred. So whenever reset is activating, what happens? All the registers present in transmit buffer and receiver buffer are cleared. Status and control parts are also cleared. Okay, then other is RXC bar. RXC bar receiver clock bar pin. Okay, this receiver clock bar pin receiving the clock signal or timer or clock signal from the external device, and with that rate receiver buffer performing the receiving the bits with that particular baud rate. Then VCC is the power supply pin, and here also it requires 5 volts power supply. Okay, like that RX C bar. Similarly, TX C bar is nothing but a transmitter clock pin. Okay, transmitter clock pin. Like that, we can analyze the mainly the pin diagram of 8251. I hope you understand the block diagram as well as pin diagram. The simple thing is, for example, processor wants to send its 8-bit data to external serial port device. In which way it is possible? Processor first sending its 8-bit parallel data to data bus buffer, then data bus buffer to transmit buffer. In the transmit buffer, two registers are there: buffer register and output register. Buffer register hold the 8-bit digital data from the CPU. Okay, then the data is transmitted to output register. In that output register, that particular data is converted into serial port, and the later that serial port data is transmitted to external serial port device via TXT. The rate of transmission is controlled by TXE bar pin. Okay, so TXE just giving information to external serial port device that transmitter is empty. The transmitter, whether it's ready or not, that information is communicated to external serial port device via TXR device. Similarly, receiver operation also. For example, CPU wants to receiving data from the external serial port device. In that case, first data serial port data is transmitting from external serial port device to receiver buffer with the help of RXT with the rate specified by the RXC bar, baud rate specified by the RXC bar. With that rate, receiver buffer receiving data from the external serial port device via RXT. After receiving data, what happens? Now that is serial data. Okay, that is received by input register. Later that data will transmitted to buffer register, where it will convert serial data into parallel data, and that data will be given to internal bus buffer, and then to data bus buffer, then 8-bit data to CPU. Like that, CPU receiving data from the external serial port device. Okay, for those case we use all these blocks 1, 2, 3, 4, 5, 6 blocks. And modem control, it's one special feature performed by 8251. It is communicated to external serial port device with the help of these 4 signals, 2 are input and 2 are outputs. Like that we can analyze. And here clock frequency of 8251 is at least 30 times more than the clock range of RX bar and TX bar. Okay, right. So like that we can understand the block diagram as well as pin diagram of 8251 IC. Okay, I hope you understand this particular topic. Okay, if you really like, please kindly share my video to your friends and subscribe my channel. Thank you.